x minus 2 to the n plus 1 over n plus 1. Divide by a fraction, multiply by its reciprocal. So limit as n goes to infinity, x minus 2 to the n, x minus 2 to the first, times n over n plus 1 by x minus 2, quantity to the n. X minus 2 to the n drops. So we have the limit as n goes to infinity of, we can pull that x minus 2. And then we would keep n over n plus 1. This guy goes to 1, so that's absolute value x minus 2. So r equals 1. And notice we're centered on x equals 2. So we're looking at this happening on 1, 3. And we test the endpoints as usual. So let x equal 1. Then we have sum from 1 to infinity. Negative 1 to the n plus 1 still. If I'm letting x equal 1, 1 minus 2 is negative 1. So we have another negative 1, this time to the n over n. So that is the sum from 1 to infinity of negative 1 to the 2n plus 1 over n. 2n plus 1, notice that's always going to be odd for any natural number inputs here. Negative 1 to an odd power is always going to be a negative 1. So again, here we could factor that negative 1. Then we have sum from 1 to infinity of 1 over n. So here p equals 1, so this diverges. So we don't get to keep the endpoint of 1. Then we check out the endpoint of 3. Sum from 1 to infinity, negative 1 to the n plus 1. And then recall from the other page, 3 minus 2, so 1 to the n over n. Well, 1 to any power is still just going to be 1. So then this is the sum from 1 to infinity of negative 1 to the n plus 1 over n. So on this one, we can do the alternating series test. So limit as n goes to infinity of 1 over n does indeed equal 0. And then we check 1 over n plus 1 is indeed less than 1 over n. So this one converges by the alternating series test. So we keep the x equals 3. So our radius here is 1, 3, exclusive on the 1, inclusive on the 3. Okay, so then we can find f prime of x, and we can find integral of f of x. Let's find f prime next. So just as a quick reminder what function we were working with, f of x was sum from n equals 1 to infinity, negative 1 to the n plus 1, x minus 2 to the n over n. So then f prime of x, sum from 1 to infinity, the n comes down here, still have our -1 to the n plus 1. X minus 2 is now to the n minus 1 power, so I took 1 off the exponent, and we still have our n downstairs. Those two guys will drop pretty nicely here. So then f prime of x, sum from n equals 1 to infinity of -1 to the n plus 1 by x minus 2 to the n minus 1 power. So if I want to find r for this guy, ratio test, etc. So a sub n plus 1, x minus 2 to the n plus 1 minus 1 over x minus 2 to the n minus 1. So the limit as n goes to infinity of x minus 2 to the n over x minus 2 to the n, x minus 2 to the negative first at the bottom. That's going to push it upstairs. So limit as n goes to infinity, absolute value of x minus 2. So here r is equal to 1. We're still centered on x equals 2. So -1, 3. Test endpoints. And you will test those endpoints. Both of those should end up diverging. So on this one, it would stay as -1. I'm sorry, +1. I don't know where I got that -1. +1, +3. Again, testing the endpoints, each one will diverge. I'll let you show that on your own, just because this is one of our longest videos ever. This is a very big, cumbersome section. We'll do the integral next. So, antiderivative of f of x dx. We have our, let's see, sum from 1 to infinity still. We have our -1 to the n plus 1 power. X minus 2 used to be to the n, now it's to the n plus 1 power. So then I need an n and an n plus 1 at the bottom. And then we have our plus some arbitrary constant. So notice we're still centered on the same place. Same kind of ratio test as before. Limit as n goes to infinity of a sub n plus 1. So x minus 2 to the n plus 1 is n plus 2. N is now n plus 1, so n plus 1 is now n plus 2. Divide by a fraction means multiply by the reciprocal. Okay, so the limit as n goes to infinity, x minus 2 to the n, x minus 2 squared by n plus 1 over n plus 1, n plus 2, x minus 2 to the n, x minus 2 to the first. Lots of pretty canceling. N plus 1 over n plus 1, those are gone. X minus 2 to the n, x minus 2 to the n. X minus 2 squared over x minus 2 to the first is x minus 2 to the first left up top. So we can bring that x minus 2 out. Limit as n goes to infinity of what's left in there, n over n plus 2. So as n goes to infinity, that guy goes to 1, so same deal, x minus 2 less than 1, so r equals 1 again. And again, I will let you test endpoints. We're centered on x equals 2. On those, we get to keep both endpoints, just as a little spoiler, a little sneak preview. So on this one, you should end up at 1, 3, inclusive on both. So in 9-8, I would recommend 1 to 33, the odds, and number 47. If you have any questions, please feel free to reach out. Otherwise, I will see you next time, and stay safe out there.